That's good. Good morning, ladies and gentlemen. My name is Benjamin Martin. This is Blaine Rodriguez, my research associate. We're going to be talking about total mercury and methylmercury analysis in the Dinwoody, Gannet Glaciers, as well as some samples taken from the Swiss Alps. As a quick overview, we're going to briefly mention why we're doing this study and our purpose. We're going to go through the global mercury transport cycle as well as the methods for testing mercury. We're going to talk about the results that we achieved and then the implications that has on us, and we're going to wrap up with some conclusions. So with global warming today, a lot of our glaciers are melting, and that's becoming more and more of a problem due to the pollution that's been deposited in the glaciers, and mercury is one of the most toxic ones to us. So I'm going to go into more detail on that later, but as that melts, that goes downstream, and then we are downstream. And so that poses direct implications into our lives, and that's why we're doing this study. It's only going to get warmer, and the glaciers are only going to shrink. So the global mercury transport cycle, we have 50% of the mercury, elemental mercury in the world is from natural sources, such as volcanoes and from volatilization from the ocean. Of that 50%, 90% is from the ocean. So a large majority comes from the ocean. Out of the anthropogenics, we have 50%. A lot of it comes from the artisanal and small-scale gold mining in developing countries. And then we have metal production and fossil fuel combustion, so that's coal plants, heating and powering, and you have waste, and you have cement production. So a lot of it is from us. A lot of that can be solved by development of third world countries in their refining processes. So the actual mercury cycle is, you have it, elemental mercury can come up into the atmosphere, and then it settles as cold condensation where it moves up the mountain front, and it can stay in suspension for weeks to 2 years. So it has the capability to travel globally and deposit anywhere in the ideal situation. So once it's in the atmosphere, you have it settle in cold or wet deposition environments such as snow or just cold sinks up on the glaciers, and that's where it gets into the glacial systems or into the alpine regions. As it melts in the spring and summer, you get it into the lakes and reservoirs of the rivers, and then it goes down into the food web, and it bioaccumulates up the food web.
Thanks, Ben. So we just kind of got a brief recap of how mercury, where it comes from as far as anthropogenic and natural sources, but what do we do about it? So we had two different locations of research that we were able to use for our study. Dr. Greg Carling and a team of graduate and undergraduate students were able to go to the Wind River Range in Wyoming and take samples from two different glaciers, the Dinwoody and the Gannet glaciers, as well as some downstream samples from a location that we'll talk about later called DC Camp. We were also privileged to receive some samples way far away in the Swiss Alps, two different glaciers as well, which we'll talk about as well, to give us a little bit of a different idea of how mercury is being released in glaciers on a completely opposite side of the world. So as far as the methods of testing actually in the field and sampling, we took samples from different sites on the glacier and around the glacier in superglacial environments, so on top of the glacier, as well as downstream samples, which we'll talk about as far as DC Camp goes. The interval that we used for sampling was a 24-hour period. We sampled every other hour to give us a chance to see if there were any type of variation due to time as the day went along, as far as daytime and nighttime hours in regards to melting itself. In the field, we were able to filter our samples because we were really interested in the dissolved fraction of the mercury species, which is important to us because that's the part that has the most potential to turn into methylmercury, which is more of a concern for us. So we were able to filter those using a 0.45 micron filter and take out some of the mercury that is attached to the larger particles to get us the fraction of the dissolved mercury that we're really more interested in. So as far as lab work goes, this is kind of the most of the stuff that Ben and I have been doing for the past weeks and months. we were able to have access to a wonderful machine called the Brooks-Rand Automated Mercury System, which allows us to put in our water samples and get a pretty accurate reading of the mercury concentration in the samples that we were able to take from the field. But before we just kind of put in our water samples into the machine, we had to do a little bit of prep work. So we added several reagents to prep our samples for the process. First, we were able to add bromine monochloride, which is a powerful oxidizer, to prep our samples. We mercury spiked each sample that we took from the field as kind of a quality assurance to make sure that we weren't losing any mercury from the actual sample to the end of the test with the Brooks-Rand machine. We added hydroxylamine, which neutralizes the bromine monochloride, which the bromine monochloride can sometimes be a little too strong for some of the sensitive parts of the Brooks-Rand machine. So we neutralize that with the hydroxylamine to prevent any type of damage to the machine. And finally, we added stannous chloride, which volatilizes the mercury and allows it to be more easily read by the machine itself. This is one of our students hard at work, doing some great lab work.
So results were actually really surprising at first. We were expecting to have high concentrations of mercury in these glacier systems, and the results actually came back as low concentrations. So we're going to talk about this. DC Camp is along the Gannet stream, and so you have the Dinwoody Glacier that feeds this stream, and you have the Gannet Glacier that also feeds this stream. What's interesting to note is we're not going to show some of this data because of the way we tested it, but we took samples all along the Gannet Glacier. We had 5 samples from the Supra, and then we have all the way down the stream to help us understand mercury transport and how it goes from glacier to stream to us. But we can, the boxes are the daylight hours, and we were expecting to have a diurnal trend in our data, which is it just melts during the day and then it doesn't melt as much at night. But as you can see, during the night you also have a peak just as much as in the day where you have your peaks. And so what this shows us is that not only is it coming from the glacier, but the groundwater has a good influence on mercury transport as well. Another thing to note is the very low levels of mercury. The EPA standard is around 6 nanograms per liter, and we're well beneath that. As the glaciers go down, or the water from the glacier go downstream, it dilutes. The more water that accumulates, the more diluted the mercury samples are. So as we go on to the Alps, we also notice during these daylight hours that it just oscillates back and forth, it goes up and down, which is surprising because we were thinking, well, as the daylight occurs, you get higher melts, you get higher concentrations, but that doesn't actually show. So it just shows that we need more research, we need to understand it better so that we can have a better idea of how it actually happens. This is the other glacial location in the Alps. And this non-glacial stream is on the back side of these slopes, and it has the same range of mercury, which is another enlightening fact because it's not glacial fed, and so it shows that the mercury is coming from the topsoils, it's coming from the surrounding areas. And one last quick thing to note with our results is that the Wyoming glaciers and the Swiss Alps glaciers both had similar levels of mercury, and so they're in different continents or in different environments. They're both glacial, they're both alpine, but that's the geology varies as well.
Perfect, that's good. So Ben kind of gave us a little bit of recap on our results, and we concluded that the concentrations in the actual samples that we were able to analyze are pretty low. But kind of how does that work for us? What does that mean for us? We know that there's mercury in the glaciers, we know that there's mercury in the waters, but they're pretty low. But the fun fact about mercury is once it's transported into the watershed and has an opportunity to get into alpine lakes and rivers and streams, in anoxic environments where there's not a whole lot of oxygen, it has the potential to be transformed by bacteria into methylmercury. And methylmercury is what you hear about when you hear about food or mercury poisoning in fish and that kind of stuff, the dangerous stuff that we care a lot about. Obviously, we've all heard of mercurism, mercury poisoning, but there are also hazardous effects such as birth defects in the children of pregnant mothers, and rare and specialized diseases such as Minamata disease, which was discovered in Japan. This is a picture of me fly fishing in Mirror Lake in Hyumentas, and my wife and I are avid fly fishermen, and we love to be in these elevated aquatic environments, and they're very important to us as it is for many people in Utah and all over the world. So it's important for us to kind of preserve these environments and better understand what's going on. Obviously, we do a lot of catch and release, but it's a big problem if a lot of those fish are having that bioaccumulated mercury in their tissue, which can pose a serious health risk for us and lots of people. So in conclusion, Ben kind of gave us our purpose. We know that global climate change is a real thing and that the environment's heating up, which means that these glaciers are melting. We know that mercury is in these glaciers and it's being released downstream into the watershed. So as far as how impactful is this glacier melt on mercury levels in the stream, downstream, and in the watershed, from our research and data alone, we know that the levels are pretty low. Like we said, we know that mercury can turn into methylmercury and bioaccumulate and kind of continue to get worse and worse. So it's a big problem for us as far as protecting our environment that we love and care about, and for protecting ourselves as far as health risks and environmental hazards. And so it only gives us further motivation and drive to continue our research and understand a little more about the process of it being released into the watershed and some of the potential hazards that are associated with it. Thank you.
We have plenty of time for questions because there's no, the next author is not going to be here. So ask away if you have questions.
I have a question. Just talking about your sampling areas, you just did it throughout the day. Was that just like in the same spot you sampled, or
Yeah,
you
so
have several places around?
So yeah, so it's in both locations. We'll talk about this one. We did it. There were two different glaciers, the Gannet and Dinwoody Glacier.
Right.
The results that we showed. So these different glaciers, we took samples at different spots on the glacier, so we're able to plot that according to time because they're in different geographic locations. But the DC campus in the same spot, and we were able to take these samples and track them over a period of time because they're in the exact same spot. And these three locations were also stationary, so we were able to track them on time and see the variation according to time.
So did you guys sample the melt water, or did you actually sample the ice?
We did. So we weren't in the field, but the samples that were collected were melt.
Or melt? Okay. So have you thought about doing the same type of analysis with ice cores? We've got ice cores, you know, in Colorado and Denver, and the USGS.
USGS sampled the Upper Fremont Glacier, just south of the Dinwoody Glacier, and they already have that data. And that was part of the motivation for this study, was they showed really high mercury concentrations from like 1950 on. It's like the ice from the past. Well, I guess they collected the core in the late 90s, but yeah.
So that was one surprise, is because of that study we were expecting a much higher level of mercury, and to have such low levels we were kind of like, well, what's going on? Did we miss it? Did it melt off earlier? Are we just not hitting the target layers? But with some of the data we didn't show is the samples collected all over here, the super glacier, or the melt that came from directly to the surface, was like 1.4 nanograms per liter. And so it was significantly higher, but you had that dilution effect as it melted and mixed in with the groundwater and other water towards the DC camp. So it was partially higher, but it wasn't extremely higher in comparison to the 4 or 5 that the ice core sample had.
Well, you know, just looking at the data, which is the small data set, I would think that maybe the mercury has decreased in time or increased in time. You know, you have to say, well, where did the USGS, where did they collect their data? You know, and what age was it? And where did you guys collect your data, and what age was it? And so it looks like there's a lot more work to be done.
Absolutely.
And then also, you know, to test the lakes around there and the fish. I don't ever recall hearing any high levels of mercury on any fish in Wyoming, but you know, maybe there is. Maybe there needs to be more work on that too.
Yeah, I was gonna ask. So with the ability of mercury to kind of travel kind of wherever it wants within this 2-year period, would you expect to see the same thing in glaciers all over the world then?
So that's the great thing about our study is obviously Wyoming and Switzerland are pretty far apart, and we saw similar concentrations in both glaciers, and actually similar concentrations in this non-glaciarized sample as well, which wasn't even part of these glaciers. We saw similar concentrations all over the place. And that's why this is such an important topic, because you have industrializing countries such as China and India. They're using kind of not clean energy, but burning a lot of coal, pumping mercury into the atmosphere, and gives the opportunity to travel all around the world, being that it can be suspended for such a long time in the atmosphere.
So anywhere you have those precipitation of the colder, so anywhere it would snow or it would have colder rain, so kind of higher up in the elevations, you would find those.
So we went to like mountain glacier, you could probably see some.
Yeah, it'd be great. Need something to research.
Any other questions?
Well, we'd like to thank Blaine and Ben for that great presentation, and then
We have like about 15 minutes break before our next presentation.